All right. So, more time?
Yeah.
A little bit? Okay.
I haven't seen one, so I have to go for it. Alright, I'll trust you. Pretty trustworthy type person.
Knock the easy one out. What quadrant can it be in? 3 and 4, right? Okay, because sine is negative, and sine is negative bottom half of the unit circle, because sine is y, so y's have to be negative, so it can be either in quadrant 3 or quadrant 4. Oh, now see, now all this got oh man, wow. Things are going to be all kinds of crazy now, because I got to go back and I got to reset. Okay, quadrant 3 or quadrant 4? Love it. What's up? No. Okay. Okay. Just how I do it. Crazy like that. Okay. Sine of negative t is going to be the negative sine of t, right? If I go the opposite way on the unit circle, then all of my values are going to be opposite. Correct? For sine, because I'm going, instead of going up and around, I'm going down and around. So that's going to be negative sine of t, which means that's going to be negative of negative 12/13, which is going to be 12/13. Agree? Okay. Sine of t plus pi, halfway around the circle, that's going to be the opposite of sine of t. So that's again going to be, this all the time now, 12/13. Agree? Yes? Okay. Sine of t minus 2 pi. That's one whole lap around. So that's going to be the same as sine of t. Right? Good so far. Okay. Hammer time. Agree? Yes? Yes? Yes. Why does it have to be plus or minus 5/13? Okay. And I was solving, right? Okay, so that's one reason. Trigonometrically, why does it have to be plus or minus 5/13? Because which quadrants can this one be in? 3 or 4, right? So in quadrant 3, what is cosine? Positive or negative? Negative in quadrant 3. In quadrant 4, what is cosine? Positive. So we haven't deciphered which quadrant we're focusing in on, so it has to be both positive and negative 5/13. Cotangent. Cotangent is cosine over sine. So that is going to be plus or minus 5/13 over negative 12/13. Thirteens cancel each other out, so that leaves me with the negative sign kind of cancel out. It doesn't really cancel out anything because you got the plus or minus there, so we're just going to keep the plus or minus there of 5/12. Agree? Questions on any one of those?
I just don't understand C. How did you get your answer?
Because in the obviosities packet that we went over Tuesday and Wednesday, okay, we said that if we are going halfway around the circle, that the sine values are going to be opposite. Cosine values would also be opposite too, because you're on the other side of the circle. Okay? So if I just randomly put a t value here, if I go halfway around, now I'm down here on the bottom, so both my sine and my cosine values are opposite because I'm on the opposite side of the circle.
Okay.
Okay? It was a slow fall, and I saw it coming the whole time. Yes, ma'am? Okay? Just when you think you have all the answers, I go and I flip the question. Okay? Now, find me the angle. Not find me the sine or the cosine or the tangent or the cosecant or the secant or the cotangent. Find me the angle now. Okay? So, let's talk about this. The directions say, and directions are extremely important, okay? Because it kind of tells us where we need to look, right? Okay? Directions say find theta without using a calculator. That's good. We don't need no stinking calculators. Okay? But then it says theta is an acute angle. What does that mean?
Because there could be two values for it, so we're going to write down the acute value.
Okay, so what does that mean?
Less than 90.
So where is that?
Between 90 and 0.
So where is that on the unit circle? Quadrant 1. So we're only looking in quadrant 1 because for all of them, there's an extra pair somewhere out there. Okay, whether it be in quadrant number 2 or quadrant number 4 or quadrant number 3, depending upon what's what. Okay? Sine has the extra pair in quadrant 2, tangent has the extra pair in quadrant 3, cosine has the extra one in quadrant 4. Okay? So we're limiting ourselves to just quadrant number 1. Okay? That's what that says. We're limiting it just into quadrant number 1. So where in quadrant number 1 is the cosine the square root of 3 over 2? So cosine is x, right? So the x value is here. That's the square root of 3 over 2. So that's what? 30 degrees. But because we like radian measures better, pi over 3? Pi over 6. Okay? I like pi over 6. So theta here would be pi over 6. Okay. Where in quadrant 1 is the tangent. I used green before, so let's use purple this time. So tangent is y over x, right? So if those are going to be equal to 1, Gabe, where are we? Pi over 4, because they have to be the same, right? So x has to equal y, or y has to equal x, and that happens at pi over 4. So theta is pi over 4. Sine is y's, right? Immediately I want to change this. I want to go like this. I like that better. And it doesn't look like I made a fraction out of it. Okay? So where is the y value 1/2? What? Pi over 6. So theta here then would be pi over 6. Okay? Try those two. Where am I looking? Where am I looking? Which quadrant am I looking at? I'm only looking in quadrant number 1. Okay? All right? So where in quadrant number 1 is the tangent equal to the square root of 3? That's y over x, right? Okay. Which one can I automatically throw out? Pi over 4. Why can I throw pi over 4 out? Doesn't have square root of 3 in it, so it's gone. What else can I throw out? No. What? 0 or 2 pi, right? Because it doesn't have square root of 3 in it. It gone. What else can I throw out? Pi over 2. Because pi over 2 doesn't have it in there. So I'm down to either pi over 3 or pi over 6. Right? Okay? So if I try 1 and I get the square root of 3, I got it. If I try 1 and I get 1 over the square root of 3, it's the other one. Okay? Right? Okay? So you're saying pi over 6? Is that what everybody's saying? Or are we throwing out pi over 6? Throwing it out? Okay, so we're trying pi over 3. Okay? So pi over 3 would be the square root of 3 over 2 divided by 1/2. That's going to be the square root of 3 over 2 times 2 over 1. The 2's cancel each other out. Leaves me with the square root of 3. Square root of 3 is the square root of 3. So, yepper, theta here is pi over 3. Okay? Side note, just so you see, if I would have tried these two down here, I would have gotten 1/2 over the square root of 3 over 2, which would have been 1/2 times 2 over the square root of 3, which would have given me 1 over the square root of 3, or the square root of 3 over 3 if I rationalize it. Okay? Which isn't that one, so it's got to be the other one. Okay? See what I'm saying there? Okay? All right? Cosecant, square root of 2. Which 4 can I throw out? What? So I can throw out
Pi over 2, pi over 3, pi over 6, 2 pi.
and 0, 0, 2 pi. Yeah? Okay? So I can throw all those out because all of those have either 1s and 0s, the pi over 2 and 0, or they have a square root of 3 in them. Okay? So let's focus in here on cosecant is, what's that, 1 over y? Which is 1 over the square root of 2 over 2 if I use pi over 4, which is 2 over the square root of 2, which rationalizes to be 2 square roots of 2 over 2, which is the square root of 2. So, yep, this is pi over 4. Yes? Love it. Huh? Try those 3. All right, so which quadrant am I looking in for this one? 2. Okay, so where in quadrant 2 is cosine negative square root 3 over 2? Five pi over 6. Yep. Okay. Which quadrant am I looking at for this one? 3? Where in quadrant 3 is the tangent? Tangent, remember, is y over x. Where is the tangent equal to the square root of 3 over 3? 7 pi over 6. Okay. I'm going to do, in quadrant 3, I'm going to do 4 pi over 3. Okay. I know it's got to be one of those two, but I want to again show you that what happens when it's not the one. Okay. All right. So 4 pi over 3 I'm looking at. So that's going to be negative square root 3 over 2 divided by negative 1/2. That's going to be negative square root 3 over 2 times negative 2 over 1. Those cancel out. Gives me square root of 3. Okay, so that one didn't work out for me. Wasn't the same, so it's got to be the other one. Or if you wanted to see that math, it would be negative 1/2 divided by negative square root 3 over 2. That's going to be negative 1/2 times, It's going to be negative 1/2 times 2 over the square root of negative square root of 3. Cancel, cancel. Going to be 1 over the square root of 3, which simplifies to root 3 over 3. So therefore it is 7 pi over 6. Agree? Okay. Cosecant is negative 2 in which quadrant? Okay. Cosecant, I'm going to take this one a little different way too. Okay, because normally we'd be thinking cosecant is 1 over y, right? Okay. So I'm going to think of this one as, instead of thinking of it as cosecant, I'm going to think of it as 1 over the sine of theta, right? Because that's what cosecant is, 1 over sine. And that's going to equal negative 2. Well, if I reciprocate this left side, what do I get? I take the reciprocal of 1 over sine. I get sine of theta over 1, right? So that we will just call sine of theta. Well, if I reciprocate one side, I got to reciprocate the other side, right? Yeah? So what's the reciprocal of negative 2? Negative 1/2. So where in quadrant number 4 is sine equal to negative 1/2? Where are we at? 11 pi over 6. Yep. Okay? Agree? Now, one more thing for tonight that I strongly encourage you to do is I strongly encourage you to watch the Origins of SOHCAHTOA video on the interwebs this tonight. Okay? So we have it posted in our It's Learning page. Get back out here into resources. We have it posted here in our It's Learning page under Unit Circle sections 4.2 and 4.3. That's what we're in right now. And it is this video right here. The Origins of SOHCAHTOA. Watch that tonight. Unless you enjoy being on the struggle bus. Okay? If you're a fan of your seat on the struggle bus, don't watch it tonight. Come to class all kinds of confused tomorrow. If you don't want to be confused tomorrow in class, you're going to want to watch that video this evening. It's a 15-minute video. Talks about where SOHCAHTOA comes from. Okay? All right?